Hello folks, this is 2019 May-June paper 2-3 and the question number is 6. So it's paper 2 here. The question is related to electric current. So it's the first question says define the ohm. So ohm is the SI unit of resistance, and it's equal to the ratio of the unit of potential difference and the unit of current, which is voltage volt per ampere. Now the second question shows a battery of electromotive force EMF E and internal resistance 1.5 ohm is connected to a network of resistors as shown in figure 6.1. So these are the network of resistors. This is known, this is not known, this is also known. Resistor X has a resistance of 8.0 ohm, 8.0 ohm. Resistor Y has a resistance of 2.0 ohm. Resistor Z has a resistance of RZ, which is unknown. The current in XC is 0.60 ampere. So in this branch it is 0.60 ampere, and the current in YE is 1.8 ampere. So that means the current flowing through this resistor and this resistor both is same, which is 1.8 ampere. Now number 1 says calculate the current in the battery. So it means we have to find this current I. So from Kirchhoff's law, what we have to do is at this node the incoming current should be equal to outgoing sum of outgoing currents. So that's why this I should be equal to the current going here is 1.8 ampere and the current going here is 0.6 ampere. So that's why it's equal to 8614 2.4 amperes. So the current is 2.4 amperes. Now we have to find the resistance RZ here. So one thing that you have to remember is let us name these points as let us say A, B. So if I consider this branch, we have VAB is equal to this current is 1.8 into the total resistance along this branch, which is equal to 2.0 plus RZ. So if I consider this branch, and if I consider the other branch, if I consider this branch, then VAB should be equal to the current flowing through here, which is 0.60 ampere, and the resistance here, which is 8.0. Since both of these PDs are same, so we must have this expression equal to this expression. So I must have 1.8 bracket 2.0 plus RZ should be equal to 0.60 into 8.0, which gives me, so these twos are 3.6, 6 plus 1.8 RZ will be equal to, it is a 48, so it is 4.8, which gives me 1.8 RZ is equal to 4.8 minus 3.6 equal to 1.2, which further gives me RZ is equal to 1.2 divided 1.8 and is equal to 0.66666. I can write it as 0.67 ohm. So 0.67 ohm here. That's the value of RZ. Now EMF. The EMF of the circuit should be equal to, EMF is equal to, first let us go through this. Since the current is I here, this is also I, this is also I. So the EMF will be equal to the sum of all PDs throughout the circuit. So that's why the PD through here is equal to this I into 1.5 plus the PD here. So I can directly consider this PD here. So this PD is equal to VAB. So E is equal to the internal potential drop, which is I into 1.5 into plus the external potential difference. So this is equal to I is we have found here 2.4 into 1.5 plus VAB is equal to either I can do from here or from here. So let us do it from here. It's equal to current is 0.60 into resistance is 8.0. So equal to so this is equal to 2.4 into 1.5 is 3.6 plus this thing is equal to 4.8, and that gives equal to 8614. This is 8, so 8.4 volt. So E equal to 8.4 volts. Now in the next page we have this problem. So next page becomes even more tougher here, even more tougher. So let me place it somewhere here. Now it says resistors R and X and Y are made of wires. Of course, the two wires have the same length and are of same material, same metal. Same metal means that the resistivity is same. So we have to find the ratio of cross-section area of wire X and cross-sectional area of wire Y. So that means, so I have to do it like this. The resistance of a resistor is equal to rho L by A. So that means I have Rx is equal to rho L by A X and Ry is equal to rho L by A Y. So this means Ry by Rx is equal to rho L by AY, and this is rho L by AX. This goes, when I shift it here, it's equal to AX by AY. So therefore AX by AY will be equal to Ry by Rx. So we have to go through the first page once again. So let me fold it here so that I can have a clear view of the first page. So here the value of Rx is, so Ry is this, so it's equal to 2.0 Ry, and the value of Rx is this is 8.0, so it's equal to 1 by 4 or 0.25. So Ax by Ay is equal to 0.25. Now we have to find the ratio of average drift speed of free electrons in X and that of Y. So here also again the same thing here. I is equal to EVAN. So I must have Ix is equal to E Vx Ax N, and Iy is equal to E Vy Ay into N. So I need this, so I must have let's take the ratio here. Ix by Iy is equal to E Vx Ax N by E Vy Ay N. So N goes, this E and E also goes. What I need is this is, so I must have Vx by Vy is equal to Ix by Iy into it is so when it goes here it will be equal to Ay by Ax so equal to. Now again let us go for this thing Ix and Iy stuff here. So let's turn over here. The current through X is 0.6, so 0.6, and the current through Y is equal to 1.8 into Ay by Ax. So here we have got Ax by Ay equal to 0.25 or 1 by 4. Ay by Ax should be equal to 4:1, so it's equal to 4 by 1. So this gives us, it's equal to 4 6 24, 2.4 by 1.8. it will be equal to 6 3 18, 6 4 24, so it will be 1.333 and so on. So when I write it in proper number of significant figures, it should be equal to 1.3. So that's the answer for the whole question.